Graphs of exponentials. Exponential graphs have the basic form y equals a to the power x. So you can see immediately why they're called exponentials. We have x is our exponent of a, where a is a number that is not 0. In fact, it's given as a is greater than 0, and it does not equal 1. Because 1 to the power anything is 1, and it's going to be a very boring graph. Now, the form that this takes is an exponential graph, quite obviously, by which I mean very slow gradual growth and then hurtling up really fast. So any exponential graph will look like that. And if you think about the sort of things that have exponential growth, I mean, this is your classic doubling things, like the grains of wheat on a chessboard. Double it again, double it again, double it again. You get very, very fast growth eventually, very quickly. It's like playing a game of 20-48. You know, you're playing around with 2, 4, 8, and then all of a sudden you're 10-24. If you're really good at it, of course. So if you're not certain how those two examples relate to the exponential, catch me in class. Now, things to note about the exponentials. Do remember what happens when we've got negative indices. So let's just start with y equals 2 to the power x, which is basically the easiest we can do. Now, let's just start with positives because that's nice and easy. Obviously, 2 to the power 0, anything to the power 0 is 1. So most of these that we're doing are going to pass through 0, 1. Anything to the power 1 is itself, then 2 squared is 4, 2 to the cubed is 8. So those are easy. These are also easy, but just remember that let's not even do that. A to the power of negative 1 is the same as 1 over a to the 1. Remember that a to the power of negative 2 is the same as 1 over a squared. So it's actually quite easy to work these out, because this is going to be, when x is negative 1, y is 2 to the power negative 1, which is 1 over 2 to the 1, which is a half. So it's actually mostly easier to just work these out as fractions rather than decimals. Here where x is negative 2, that will mean y is 2 to the power negative 2, which is 1 over 2 squared, which is 1/4. Now what you can see from this is that no matter how far down we go in the negatives here, I could get to negative 100, and I would get, when x is negative 100, y is 2 to the power negative 100, which is 1 over 2 to the 100, which is a really, really, really big number on the bottom of this fraction, which means this fraction is a really, really, really small number, but it doesn't ever reach 0. We're always going to be dividing by larger and larger numbers, which means we'll get closer and closer to 0 as we follow down here, but we're never going to actually reach it. Now, a graph that does that is said to have an asymptote. Now, I'll write that word down for you. Sorry, my working got very messy here. This is an asymptote. It's when it approaches a value and gets closer and closer and closer to it, but never actually reaches it. And we give the asymptote as a horizontal or vertical line. So the equation of the asymptote here is the x-axis, that is y equals 0. So we'll be often asked for the equation of an asymptote. Now, when we are sketching these, we don't have to be drawing up a table of values. We're sketching based on our knowledge of them. So when you sketch any graph, you want to show any intercepts, and obviously there's only going to be a y-intercept because we're not getting down to the x-axis. The easiest place to show the y-intercept is of course we're going to show the y-intercept where x is 0, and that means it's going to be 1. If we started messing with these graphs and having more complicated rules, of course that can change, but for now we're just looking at the basic forms. So you draw your little set of axes. We've got x and y. 3 to the power 3 to the power 0, where x is 0, is going to pass through at 1, so we show where that is. And the idea is you always show at least 2 points. The next point that is most easy to show is going to be, of course, where y equals 3, that is where x is 1. So there's a point here at 1, 3, and then sketch in your asymptote and your increase. Y equals 3 to the power x, label your line. So that's sketching a basic exponential. Now when we start throwing other negatives in, so for example here I've got y equals negative 3 to the power x. Now remember that powers happen before multiplication, and this is effectively y equals negative 1 times 3 to the power x. The negative is not given in a bracket. If this was negative 3 to the x, that would be very different. Sorry, in brackets. But negative outside the front there, 3 to the power x is negative 1 times 3 to the power x. What that will do is it will reflect the graph of y equals 3 to the x in the x-axis, because all of these values are suddenly going to be made negative. So it's very easy to just sketch that. It's going to have its intercept at negative 1 because it would have been at 1. Sorry, I'll move up here. And I made that negative. And it's going to have its other point at 1, negative 3. Because it's the horizontal reflection of this, because all of these values just got made negative y values. So you can, sorry, I don't like drawing curves at that angle. Come in and draw as best as you can your line. Label it. And the last sort that we might have, of course, is when I've got 3 to the negative x. And if you think about it, that will mean that effectively what happens here is going to be switched. So instead of really low in the negatives and swooping up, we are reflecting our graph vertically in the y-axis. So we'll still be intercepting at 1, but our point that we want to put in will be at negative 1, 3, because we're reflecting in the y-axis, and negative 1, 3 is the easiest one to do here. Negative 1 as our x, I would get negative negative 1, which is 1. So I've got that 3. And again, draw your gradual increase and then scooting off up there and label it. So that's an introduction to the exponentials, their basic form, how we get these really small fractional values, and the reflections that happen and how to sketch them.